All right, so in chapter 5, section 1, we're dealing with integration. So integration is doing backwards derivatives. With derivatives, you find a slope. With integration, you're given a slope and you're asked to find the original function, basically. And the text, they'll call what you're looking for is the antiderivative, and they'll call it a capital F. You're looking for an antiderivative, right? So if you're given some function, if you go backwards from the function, you get the antiderivative. If you take the derivative of your antiderivative, you get back your derivative. So again, the processes we're working backwards. In the previous chapters, we've been finding derivatives. On this one, we're going to be given the derivative, and we're going backwards. The big thing to notice, they talk about integral notation. So integral notation is this little symbol here of some function, again, which is the derivative of something. And when we go backwards, we're doing it with respect to x. And so when we go backwards, we get this antiderivative, our original function. And then there's always going to be some plus c when we're just dealing with, it's called a indefinite integral. It's indefinite because there's no bounds. Later on in the sections, or in this chapter, we'll see bounds on this symbol. So, but it's plus some constant. So I want to kind of describe that plus c for a second. So if I have a function, let's say I have 2x. And if I go backwards from that function, right, 2x, I'll show the rule that would do this. This would be the original function because the derivative of x squared is 2x. I think we all would agree with that from the previous sections. So I started off with a 2x, but now I have an x squared, right? So this is the derivative, this is the antiderivative. But 2x is actually the slope generating function for a lot of things that look like x squared plus 5. It is also, because if I take the derivative of this, I get 2x. It could be minus 4, right? Because the derivative of this is still the 2x. It tells me my slope at any given point. So just because this thing is lower or higher, it doesn't mean that that slope at that point has changed at all, right? So if I do plus 5, right, and I have this slope generating function that we find is 2x. So the derivative of x squared plus 5 is 2x. If I evaluate f of negative 1, I get negative 2. So the slope at the point negative 1 into my original function would be, what's negative 1 squared is 1, so that's 6, right? So the slope right here is negative 1. Now, if I look at this equation, minus 2, right? My derivative is still 2x. The slope at negative 1 is still negative 2. Right? That's not going to change. The point where I'm at now would be negative 1, but that slope here is still negative 2. That hasn't changed. So the slopes are always the same. So that's why when we have some derivative and when we go backwards, we end up putting this plus c attached to it, because if there's any constant it could be affected by, and it still doesn't change the slope at a particular value. On the next page is where we get some of our basic rules for integration that we'll be looking at in some of the problems. So in number 2, we have the integration of 2y to the negative 5. So looking at some of these rules, I could just pull out that constant so the 2 comes outside, and then I could use this power rule because I have y to the negative 5. So it would be a combination of this constant multiplication or multiple rule and a simple power rule. And so I'm going to do a supplement for number 2 to show you how I'd work that out. Also, number 5 is a little bit more complex. I don't see anything over here with square roots in it, but I do see something that I could turn into a rational exponent. So I have x to the 1/2 power rule. I have 1/5 times x to the negative 1/2, right? Because the square root of x is x to the 1/2, but just to bring it up top to make it look, to be on top, I can make it x to the negative 1/2. So when I do that, I can use this nice little power rule. So I'll do a supplement for 2 and 5. I also want to look at number 9. We are given a marginal cost, right? And it's asking me to find my cost function. So what I would have to do is find the antiderivative. I want to go backwards from this. And then it's also told me what my fixed cost is. Again, when you're cost, you're dealing with a variable cost and a fixed cost. So they've helped me figure out part of my equation for my cost function, but that plus c, that's your fixed cost. So I'm going to have to do a little bit of substitution to help me find out what my c value is. And again, I'll show on a supplement how to do that. But make sure you check over these rules that are in the text, please.